Today, we are exploring a critical, yet honestly frequently misunderstood world within Power BI. We're talking about data modeling security. In real world projects, you know it's simply not enough to just have a model that calculates the correct numbers. You absolutely must control who is actually allowed to see those numbers. If you don't, well, your data is going to leak to the wrong users. So today, we are going to make Power BI role level security completely accessible and super easy to understand. But first, picture a scenario that might feel a little too familiar. Imagine you've got a sales table. You have a director who is allowed to see absolutely all the data. Then you have a manager who can only see data for a specific department. And finally, you have a salesperson who is strictly restricted to a specific region, like Europe. How do you actually secure this data for all these different users without pulling your hair out or just quitting your job on the spot? And this brilliantly illustrates the crossroads so many developers face. The immediate reflex for some people is to create a total maintenance nightmare. They duplicate the report into 3 separate files, build specific filters for each one, and just share them out. But imagine having to update a calculation across dozens of duplicated files. It's just not going to work. The smart solution, the one we're focusing on today, is keeping one single data model, one report, and applying a row-level security component directly on top of it. By leveraging the engine's built-in context, Power BI dynamically filters the report based on whoever is viewing it. It's pretty amazing. So here is our roadmap for this explainer. First, the data security dilemma. Second, 3 levels of security. Third, static versus dynamic RLS. Fourth, building dynamic RLS. And finally, we'll cover the filter direction trap.
Starting off with Section 1, the data security dilemma.
Now, before we hide any data at all, remember this: a clean data model is the absolute prerequisite. If your model is a chaotic mess, your security is going to be a nightmare. But assuming your model is clean, what exactly are we hiding? Well, we basically have 3 distinct pillars. Scenario 1 is table-level security. This is for those extreme cases where a table contains highly sensitive finance or contact data, and you literally hide the entire table from certain users. Scenario 2 is column-level security. Maybe the employees table is totally fine for everyone to see, but the salary column needs to be hidden. But scenario 3 is by far the most common, and that is row-level security. Which leads us right into Section 2, 3 levels of security. Let's really zoom in on that third pillar, because it's the technique used in almost every real-world project. The crucial point is understanding exactly what row-level security, or RLS, actually is. It means the entire table is visible, all the columns are allowed, but the users won't see all the rows. A salesperson only sees their assigned region, while the director sees everything. It is the ultimate savior for our whole maintenance nightmare scenario because it allows us to build one definitive report that seamlessly adapts to the permissions of the person viewing it. Moving right along to Section 3, static versus dynamic RLS. Okay, so once you decide to implement RLS, you face a choice. There are 2 distinct ways to build it, and it's super important to know why you will likely outgrow one of them really fast. Let's compare them side by side. In static RLS, you actually have to create a separate role for every single value in your data, like one role for Europe and a totally different role for the US. You also have to manually assign users to these roles inside the Power BI service. As our source points out, if you have 3,000 users, you simply do not have the time or, let's face it, the sanity to map them all manually. That's exactly why dynamic RLS is the best practice for larger projects. With dynamic, you create just one role using a DAX calculation, and user assignment is completely automated through a security table sitting right inside your model. So how do we do it? Let's get into Section 4, building dynamic RLS. Here is your practical playbook for constructing this dynamic, data-driven security model in Power BI. It happens in 3 really logical steps. First, define your specific security requirements. You should never apply random filters just based on a gut feeling, okay? Consult your security officers to confirm that, for example, data must be secured specifically by region. Second, you add a special security table to your data model that maps user emails directly to their allowed regions. And third, you write a single DAX role to bridge the current user to that security table. And that brings us to the magic ingredient. Because to bridge the user to the model, Power BI has to know exactly who is opening the report. It does this using a genuinely fantastic DAX function called user principal name. It's a bit of a mouthful, but when a user opens the report, this function executes and captures their email address behind the scenes. We then use a DAX filter expression to tell Power BI to check that exact email address against our security table. You know what's amazing about this dynamic setup? It's how incredibly secure it is by default. As highlighted in our source material, If a user, let's call him Dan, opens the report, Power BI captures Dan's email. But if Dan has no record inside our mapped security table, the model defaults to absolute zero access. Dan will see zero sales, zero customers, zero products. He will literally be completely blind to the data.
Finally, let's talk about Section 5, the filter direction trap.
So, picture this. We have our security table, we have our DAX function, and it seems flawless. But consider this crucial question. You've set up everything correctly. You have a user named Alice who is mapped to a region that only has 4K in sales. She logs in, but her screen shows the grand total of 10K in sales. The security is leaking. Why on earth is she seeing all the data when RLS is applied? Well, the culprit here is almost always the filter direction. This defines the exact path that your security filters travel across your table relationships. Remember, the DAX expression we wrote filters the security table, not the entire data model directly. That filter then has to travel. If the relationship arrow points backward, meaning from the fact table to the security table, the filter simply does not travel. The data doesn't get filtered at all, resulting in a massive security leak where absolutely everyone sees that 10K total. Furthermore, you have to decide exactly how far you want that filter to travel. In a classic star schema, the filter direction usually goes from the dimensions down to the fact table. So Alice's sales dollars will successfully drop to 4K, but she might actually still see all the customers and products in the system. If your security requirements dictate that Alice shouldn't even see the names of customers outside her region, you must change the cross-filter direction to both. This forces the security filter to travel through the fact table and back up into the other dimensions, successfully hiding restricted customers and products from her view as well. Ultimately, building relevant security isn't just a shiny little feature you slap onto the end of a project. It is a fundamental, structural part of data modeling itself. If your tables and filter directions aren't correctly aligned, I promise you even the best DAX code in the world won't protect your data. So, as we wrap up this explainer, I want to leave you with a provocative thought. If you were to go and look at your organization's current Power BI models today, is your security truly baked into the structural foundation of the relationships, or is it just a fragile add-on waiting to leak? Think about it. Thank you so much for joining me today, and keep exploring.